Welcome back to the Deep Dive. So our mission today is pretty straightforward. We're diving into the winter storm risk assessment for December 2025 across Eurasia. We're talking Europe, Russia, the Caucasus, and the sources we have, they're pointing toward a forecast that's, well, unusually confident.
And that confidence is really the key here. I mean, the assessment signals a significantly elevated risk for these high-impact winter events. But the predictive skill isn't coming from local trends. It's driven by this unique, almost textbook convergence of global atmospheric drivers. It's a synergy that really locks this forecast in.
And here's where the material gets truly fascinating for me. The entire risk profile, the root cause of all this, it doesn't start near the ground. It begins miles up in the atmosphere. We're talking about the stratosphere.
Precisely. The dynamical models are flashing a critical high-confidence signal. They're projecting an anomalous weakening, basically a disruption of the stratospheric polar vortex, the SPV. And that's slated for late November, right into early December.
Okay, let's unpack this for a second. The SPV, that's like a giant fence high up in the atmosphere that keeps the coldest Arctic air locked up.
It's a great way to think of it. A fence.
So if that fence collapses, it's not an instant cold snap down here for us, is it? I mean, if it breaks down miles up, why does it take, 10 to 30 days for us to feel the effect?
That's the crucial lag. The disruption in the stratosphere, it sends a mechanical signal downwards into the lower atmosphere, the troposphere.
Okay.
And this signal, it forces a strong bias toward establishing a negative North Atlantic oscillation, the NAO phase. That right there is the key mechanism that brings the cold air south.
So the NAO is the delivery system. Got it. What does that pattern actually look like on the ground?
Well, the NAO maximizes the pressure gradient you need for these sustained cold outbreaks. So instead of the usual mild westerly flow from the Atlantic, you get this powerful, persistent blocking pattern.
A block?
Yes. It acts like a giant freezing pump, pulling that frigid continental air westward from an already robust Siberian high.
Which the report shows is being strengthened by all that late autumn snowpack.
Exactly. And what's important to realize is this. The report explicitly notes that even with all the warming trends we've seen since the 50s, conditions like the extreme cold of 1963 are still physically possible when the atmosphere is forced like this.
Wow. That context alone really elevates the risk. So let's bring that down to ground level. Where are the specific regional danger zones? Where is this collision going to be most violent?
We see West and Central Russia facing a high risk. The dominant feature there is sustained heavy snowfall, prolonged blizzards.
Okay.
But crucially, the forecast warns of an elevated potential for damaging rain-on-snow events. ROS events.
Oh, that's a nightmare scenario.
It is. You get a slight temporary warm-up, rain falls on the snowpack, and then a rapid refreeze, a flash freeze. That creates this heavy, dense ice accumulation that just cripples infrastructure, power lines, transport, all of it.
And then the assessment singles out the Caucasus region as a severe risk zone. That sounds like multi-layered danger there.
It absolutely is. That negative NAO setup funnels these intensified, moisture-rich cyclones from the Black Sea right into the high mountains.
So you're taking all that moisture and just ramming it into a mountain range.
Exactly. And you get this dramatically enhanced, extremely heavy snowfall. And the severity is just multiplied by the terrain. That heavy precipitation rapidly increases the vulnerability to cascading geohazards, like landslides and mudflows.
So what's the bottom line here? If you're in logistics, energy, civil planning, what's the immediate focus?
The focus has to be on mitigating infrastructure vulnerability from these rapid phase changes, the severe icing, the high wet snow loads, and that flash freezing. The biggest failures we've seen in past winters often weren't from the depth of the snow, but from the sheer weight and the ice.
A huge lesson. It's resilience to icing, not just the cold. Okay, a final provocative thought. While La Niña is a background factor, the real advantage for forecasters comes from monitoring precursor signals. Things like the Madden-Julian oscillation progressing into a high-amplitude phase 7 in late November. Watching these shorter-term tropical forces helps confirm the energy flux needed to actually trigger that stratospheric disruption. It makes that cold air surge almost predictable within a narrow window. It just shows you how connected the entire planet's weather system really is. Something for you to mull over as we head toward December.